Alright, so in this problem I have 7 to the power of x plus 7 to the power of x plus 7 to the power of x plus 7 to the power of x is equal to 28. So, to solve this problem, I'm going to first start by factoring out 7 to the power of x on my left-hand side. So I get 7 to the power of x times 7 to the power of x divided by 7 to the power of x is equal to 1. So I get 7 to the power of x times 1 plus 1 plus 1 plus 1 is equal to 28. Now 1 plus 1 plus 1 plus 1 is 4. So I get 7 to the power of x times 4 is equal to 28. And now if I divide both sides by 4, these two cancel out and I get 7 to the power of x is equal to 28 divided by 4, which is also 7. So I get 7 to the power of x is equal to 7, and obviously just at first glance we get x is equal to 1 because 7 to the power of 1 is equal to 7. However, also, if this was a problem like 9 to the power of x is equal to 27, we couldn't just, x isn't going to be a whole number, so the proper way to do this is to make both of these the same base. So 9 is the same thing as 3 squared. So I get 3 squared to the power of x is equal to 27 is the same thing as 3 to the power of 3. So I get 3 squared to the power of x is equal to 3 to the power of 3. If I have something from a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x is equal to 3 to the power of 2x, which is equal to 3 to the power of 3. And now that these two are the same bases, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 2x is equal to 3. And now if I divide both sides by 2, I get x is equal to 3 over 2. So that's how you typically solve these types of exponential equations. Now going back to this problem, we got x equals 1. So now, to check, and it's very important to always check your answer in an equation because you may have gotten it wrong. So my equation was 7 to the power of x plus 7 to the power of x plus 7 to the power of x plus 7 to the power of x is equal to 28. So we got that x equals 1. So if I plug in 1 for 7, I get 7 to the power of 1 plus 7 to the power of 1 plus 7 to the power of 1 plus 7 to the power of 1 is equal to 28. Now from here, 7 to the power of 1 is the same thing as 7, right? So I get 7 plus 7 plus 7 plus 7 is equal to 28. Now this is the same thing as 28. So I get 28 equals 28, and this is right. Alright, so for this equation, I have 7 to the power of x plus 7 to the power of x plus 7 to the power of x is equal to 777. So I want to find the value of x. So to do that, what I'm going to do is factor out 7 to the power of x from my left-hand side because we have the same term 3 times. So now I get 7 to the power of x times 7 to the power of x divided by 7 to the power of x is 1. So I have 1 plus 1 plus 1 is equal to 777. Now 1 plus 1 plus 1 is 3. So I get 3 times 7 to the power of x is equal to 777. Now I'm going to divide both sides by 3. So these two cancel out. And I get 7 to the power of x is equal to 259 because 777 divided by 3 is 259. Now from here, I'm going to take the log on both sides. And the reason I did this is because logarithms have a helpful property that state that if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. And the reason this property is so useful is because right now, as it is 7 to the power of x equals 259, well, 7 to the power of 1 is 7, 7 to the power of 2 is 49, and 7 to the power of 3 is 343. So x is going to be somewhere in between 2 and 3, but we don't know the exact value of x, and we can't solve for it as an exponent. So now, when we drop it down and make it a real term, it's much easier to solve for x. So now what I'm going to do is divide both sides by log 7. So then these two cancel out, and I get x is equal to log of 259 over log 7. And log of 259, I can rewrite that as log of 37 times 7. Now another helpful property of logarithms is that if I have something in the form log a times b, this is equal to log a plus log b. So in this case, log 37 times 7, that's going to turn into log of 37 plus log of 7 over log of 7. And this is equal to log of 37 over log 7 plus log 7 over log 7. So now, these two are going to cancel out, so I get x is equal to log 37 over log 7 plus 1. And now, the final thing to do is to plug in the actual values of log 37 and log 7. So, log of 37 is equal to 1.568, and log of 7 is equal to 0.845. So now, log of 37 over log of 7 is equal to 1.856. So I have this plus 1, which is equal to 2.856.